Scientists have been recently able to place timestamps on the various craters on the moon and compare those past impacts with known impacts here on Earth. Sarah Mazaret at the University of Toronto stated, "We can use our closest neighbor to learn a lot more about Earth's history. With no atmosphere and no plate tectonics, the moon's surface preserves a record of nearly all of its 4.5 billion years of craters. If the moon sat through a hailstorm of impacts, Earth should have experienced the same storm, and therefore the same rate of cratering. In the past, it's been unclear how old most lunar craters are, until now." Planetary scientist Rebecca Gant from Toronto realized in 2014 that the youngest craters on the moon were surrounded by large rocks, debris excavated by the impact that formed the crater. Those large rocks absorb heat from the sun during the lunar day and radiate it back out at night in wavelengths of light visible to NASA's Lunar Reconnaissance Orbiter. Gant states that, right away you could see the young craters propping out, but the older craters were surrounded by rocks that had been beamed down to the dust over time, so they didn't glow as brightly at night. Using the few craters whose ages were already known, scientists are now able to plug formulas into their computers and timestamp all 111 moon craters. Scientists can then compare those with 38 of the largest known craters here on Earth, and compare the study.
Scientists now say those craters are lining up almost exactly.
Today I'm here with Mr. Jones and Shay. Shay, why do space debris and craters hit the moon more frequently than it appears on Earth?
Because the moon doesn't have an atmosphere, but the Earth does, and it causes the space debris to burn up.
Okay, Mr. Jones, what new technologies are emerging to fight asteroids?
Well, one of the new technologies for 2020 is the ARM program, where they have a asteroid robotic machine that is going to collect space debris, boulders, and they're going to use it to propel toward the asteroids. And by doing this, any near-Earth asteroid will be pushed away from to potentially cause the asteroid not to hit the Earth, okay, which would devastate life on Earth if the asteroid is of great size.
Okay, are there any technologies that are out now that fight
well,
asteroids?
you got ARM, and then you have Hammer. Hammer is a new one. It's a rocket propelled, where they're going to take rockets and attach to the asteroid and push it gradually. That's the only technology that's being worked on as of today.
Okay, do you think they're going to be effective?
Yes, it could be effective. I mean, one thing that we teach in physics that I teach is projectile motion. So if you can launch it and it can hit it, and if you can just push it, if you can catch it, let's say 100,000 miles from Earth, if you can push it 1 degree, then it will miss the Earth by almost 1,000,000 miles. Okay. Mm-hmm. Now, near Earth asteroids fall in that 100,000 mile range, where it's too close for comfort for people here on Earth to have it to come that close.
Okay. Well, thank you guys for your time.
You're welcome.